So today we get to talk about these things called polar coordinates. So what we've been graphing is called Cartesian coordinates. So when we do those x, y, make the little x across, those are called Cartesian points. So today we're going to learn about these little things called polar points. And a lot of people in physics and engineering like to use polar coordinates as opposed to that rectangular Cartesian coordinate that we're used to. A lot of times polar coordinates help out with when it comes to things in motion, like mechanical systems, which I know nothing about, right? I am not a mechanic by any means. So a lot of times when things move, they can be represented in like a circular pattern or motion. So that's where these polar coordinates kind of come into a nice little, come into help for them to use. So we can make them, they then, you know, those smart people, they make them into like 3D representations and they get kind of like this spiral effect. It's kind of cool. Magnetic fields work in like circular patterns. So if you're going to be like all of those types of engineers and people, you guys will be working in these things called polar coordinates. So they're kind of cool. And then, so today we're going to talk about polar coordinates, how to make a polar coordinate, how to graph polar points, and then we're going to go from taking those polar points and then, which are these circular graphs or points, and then being able to put them on a regular XY rectangular coordinate plane, so that way we can go back and forth between the two. And then tomorrow you'll do just the opposite. So you're going to take those rectangular points and then make them into nice little polar points, like lagging a little, I'm hoping. I was trying to find new colors for you guys. So when it comes to these, think of like no different than when we're graphing like our angles. They just kind of have some different names to it. So we start off with like this little point, and we call it the pole. And then when we make any angle, we always have that initial side, right, that we start with. And instead of calling it an initial side, they just call it the polar axes, since we're doing polar coordinates. And then we can make it go wherever. So I'm just going to make it go like this way. Whoops. If I can draw it straight enough for you guys. Right? And so we used to call that like our terminal side, right, where our graph ends. We know that we can draw our little arrow up here and call that theta, because that's like the angle that we're looking at. Right? And if we think of kind of like when we did our unit circle, this would have been the origin, and then this would have gone out to a point on the circle. So they like to keep that same letter. They're still going to call that little guy R. So that distance is R. And then when it comes to our point, we find our point by R theta. So this is your ordered pair. So when it comes to us being able to graph these, we can graph them by looking at whatever our R value is and whatever our angle is or our degree is. That's how we're ending up plotting them. Where for us, remember, we had to find what that XY coordinate was on the actual plane, right? So we had to sit there and figure out how far over we were for our X and how high up we were to get our Y value. So when it comes to our polar coordinates, instead of looking at that X and Y value, you just look at that R and that theta, and then you can plot it. You're like, this is making no sense. It will. It will. All right. So a few little definitions on what these letters mean. So that R, we call this a directed distance. Oops. And it's from the pole. And it can be positive it can be negative, and it can be 0. And then our little theta, guess what that is? That's an angle. And that angle, they can give it to us in degrees. And guess what else they can give it to us in? Starts with an R.
Radians.
Yep, in radians. Right. So we can graph these polar coordinates if we know degrees or if we know the radians. And they can either be positive or negative. And then it's no different than when we go around our regular circle for like positives and negatives. If we're going positive, we're going to go counterclockwise. Right? And if we go negative, like you're dropping down, so you're actually going clockwise. You guys remember those, right? And then we wrote it up there one other time, but just to write down the polar coordinate, it's always going to be r theta. Right? Instead of x and y, we always have r's and thetas. So if they sit there and they give you a point and they say r equals and theta equals, then we know it's going to be a polar coordinate, not a rectangular coordinate. Right? All right. You guys are ready to see these guys? I know you're excited. So I cheated a little bit. Where's he at? So remember how we wanted these guys to be in some circles? I just did this one so that it was nice and perfect for you guys. And then afterwards you'll have to deal with my circles. Right? So when I draw these out, we're still going to draw like that XY coordinate plane or Cartesian plane or axes, where you got your x-axis and you got your y-axis. Right? And then you have a whole bunch of circles. Really, if you just draw like 4 circles, you're probably going to be good. Uh-oh. Sorry. I'm telling you, man, it was like a rough morning for some reason today. I just couldn't get everything together. All right. So let's say they wanted us to plot this point. Uh-oh. Whoops. Need a lighter color than that. Let's go with 3 and 135 degrees. Your 3 has to, it's like, instead of, you know, when we're on that coordinate plane and you're counting over like your little tick marks, like you'd have these little guys and you'd be like, oh, 1, 2, 3. So, but now because we're on polar, you're counting each one of these circles. So this would be where your R is 1. This one would be R is 2. This would be R is 3. Then that next circle would be when your R is 4. Does that make sense? So for us to have a 3, we know that we're going to be somewhere on this 3rd circle going around, right? So now we just have to find 135 degrees. And does it have to be exact? No, right? So what quadrant is 135 in?
2.
It's in 2, right? Whereabouts in 2? Like halfway, a third?
Like 2/3 of the way.
Well, it would, like, how many degrees, if you were in quadrant 1 and you were to split this right down the middle, you know, like right here, I can't even find a good color, like right here, like how many degrees would that be? 45, right? So if we were in the second quadrant, so we had 90 and we added 45 to 90, what would we get?
135.
Oh, yeah, so it'd be right in the middle, right? And then we're on that third ring, right? So we would be right here. Right? And then if we wanted to draw that out, right, like this, this would be that initial side, or our polar axes, right, you got some arrows going on that guy, and then our angle would go right to right there. Right? So look at it, you plotted it. Sometimes I'll give it to you guys as in radians. So how about, give me a number between 1 and 6 or 7. Probably 7. 1 to 7. Pick a number. Any number. 5. I love it. So if they gave us 5 and then say pi over 4, right? So we know we have to be 5 out. So 1, 2, 3, 4, 5. So we're somewhere on this circle. Where's pi over 4? You can always convert that into degrees, right? How would you convert it into degrees?
It's 45 degrees.
Yeah, it's 45 degrees. So you could always do pi over 4 times 180 over pi, right? And that's going to give you 45 degrees. So we know we got to be 1, 2, 3, 4, 5. So right about there. If you want to, you could draw that little guy, right? Not too bad. Alrighty. So now that we have these all in these coordinate planes, or sorry, in these polar coordinates, we might want to put this into a regular coordinate plane, like the rectangular one. So we can kind of see like where the point would be. That's why I kind of always draw that X and Y axes in there. And you don't have to have that X and Y axes. They can just be the circles going all the way around. But it kind of helps us see that we could sit there and find where this is in that Cartesian or that rectangular plane. So we need to be able to take our little information that we have and then be able to somehow figure out how to turn that into a X and Y coordinate plane, right? So let's just say we had our, we'll go with the little one. That's so you know how we had this guy, right? So if we wanted to figure out what this was in that coordinate plane, we want to take that r theta and we want to convert that into an xy, right? So we kind of talked about it a second ago. If I drop this guy down and I made this a right triangle, did we know what the distance was from here to here?
Oh, yeah. It's 5.
Yeah, it was our 5, right? That was our r, right? So we can say that was our r, which was our 5, right? And then we got that cute little right triangle. And if we think of our coordinate plane, if we think of our x's and y's, if I wanted to figure out how far it was from here to here, would that be my x's or my y's?
X.
That'd be x, yep. And if I was looking, right, and I wanted to figure, oops. And I wanted to figure out how high it was from here to here, that would be my x or my y?
Y.
My y. And I got a cute little right triangle. And do we know how to figure out sides of right triangles? That'd be our x squared plus y squared equals r squared. Right? And we also knew that there was something to do with this angle, that angle theta that was in there. And if we're talking about trig, when it comes to like sines and cosines, could we figure out our, we'll start with sine, like sine theta? So from this angle, if I wanted to figure out my sine, how would I figure out sine? Sine is opposite over hypotenuse. Right. So that'd be my y over my r. What's cosine of theta going to be?
Opposite or adjacent over. Wait.
Yep.
Adjacent over hypotenuse.
Yep, which would be our x over our r. Right? And we want to figure out a way to solve for x's and y's. So if I look at my sine, can I solve that for y? So I have y all by itself. What would I do to get y all by itself?
Multiply by R.
Multiply by r, right? So I would have r sine of theta equals y. And then on my cosine, can I solve that one for x? Multiply both sides by r. So now that I have these two little formulas, right? So when I'm talking about polar coordinates, my polar coordinates, I have r's and I have thetas, right? So I'm going to plug in that r and theta, and when I plug in that r and theta, it's going to give me the y value, which I can then plot on a coordinate plane, right? And polar coordinates, they give me the r and they give me the theta, and if I use the cosine, it's going to tell me what x is. So then now I'll know what my x and my y are, right? So let's try a couple. So let's convert polar to rectangular. So in other words, my polar, that's r theta, and I want to convert that to rectangular, which is x's and y's. Right. And we just sat there and came up with, right, where our x equals r cosine of theta, right? And what's y equal? R times
Sine of theta.
sine of theta. Good job. Okay. All right. So they want us to go from, let's say, 2, 3 pi over 2. And they want us to convert that into x and y. Right? So my 2 is my r, and that 3 pi over 2 is my theta. Right? So x equals r times the cosine of theta. So x is going to equal 2 times the cosine of 3 pi over 2. So that 3 pi over 2, is that degrees or radians? Radians, right? So you have a choice. So you can plug this into your calculator the way that it is, but if you plug that into your calculator, you have to be in degrees or radians? Radians, right? What's your other option? What could you do with that radians? You could turn it into a degree if you wanted to, right? So to turn it into a degree, so we're going to do this. We're going to just sit there and say this one is in radians. Right? How do you turn it into degrees? What do you multiply it by? 180 over pi. Right? Pi's cancel out. This is going to give you 90. So it's going to give you how many degrees? It's like pulling teeth today. 270 degrees, right? So now you're in degree mode, so you can plug that into your calculator. Or you just know what the cosine of 270 is. What's the cosine of 270? Zero. So my x is going to equal 0. So I know my x is 0, so now I just got to find my y. So y equals r times the sine of theta. So y equals 2 times the sine of, if it helps, put it into degrees, right? 270. So y equals 2 times, what's the sine at 270?
-1.
-1, good job. So y is going to equal -2. So -2. Not too bad. Alright. So to help out here in the near future, you guys had some homework problems you guys need to do. But I want you guys to go through your unit circle, and I want you guys to add the tangent onto all of your coordinates that you have on there. So how do we find the tangent? So let's say we did the tangent of pi over 6. So tangent's like what over what? Yeah, it's sine over cosine, right? So this would be the sine of pi over 6 over the cosine of pi over 6. Right? What's the sine at pi over 6?
1/2.
1/2. What's the cosine? Over 2, right? So we're going to multiply by that reciprocal. Right? These babies are going to cancel. We're going to get 1 over the square root of 3. Can't leave that radical on the bottom, so we're going to multiply top and bottom by square root of 3. We're going to get the square root of 3 over 3, right? So on your unit circle, like you have your sine and cosine, right, as that coordinate point, like just right next to it, so that way, or however you want to denote what the tangent is. So you're going to go all the way around your unit circle and fill in all of the tangents, right? And really, all you got to do is figure out that first quadrant, and I already did one of them for you. So you really only have to do like 2 more in that first quadrant, and then it's just really a reflection over that x and y axes, right? And we kind of know, like, when it comes to our quadrant 1, quadrant 2, quadrant 3, quadrant 4, right? If we're talking about the tangent in quadrant 1 is going to be positive. What's the tangent going to be in quadrant 2? Yeah, negative. Yeah. What's the tangent going to be in quadrant 3? Positive. And what's the tangent going to be in number 4? Negative, right?